This problem we asked to find the domains of some common function. So there are three things we need to watch out for. The first one, denominator is not equal to 0. The second one, under the even root, had to be greater than or equal to 0. And log of anything, the argument of the log must be positive. Right, only those three things. Now, let's look at these examples. The first one we have that part. It is a polynomial function. It is defined everywhere, and it is not any of this. That one is a cube root, not an even root. So this is also defined everywhere. So all of this together, the domain is all real numbers. So from negative infinity to infinity. Next, we have a rational function. We have the denominator 2x minus 5, and that rule, denominator cannot equal to 0 because dividing by 0 is undefined. So denominator not equal to 0. We will add 5 on both sides and then divide by 2. So x not equal to 5/2. Now if we draw a number line, there's a 5/2 here. We can have anything on the right, anything on the left. So the domain of this problem, we write negative infinity to 5/2, 5/2 to infinity, and then link them by a union. Right. Next one we have this, and this is a square root. So under an even root is going to be greater than or equal to 0. So we're going to have this greater than or equal to 0. Right. Minus 4 on both sides. We have that negative 2x greater than or equal to negative 4 divided by negative 2. We have x, and that is 2. The only thing we need to watch out for is when we divide by negative number, inequality must be reversed. So that have to be reversed from greater than or equal to less than or equal to. So we will write anything less than 2, meaning on the left only. It has the equal sign, so we put the square bracket. So we have negative infinity to 2, the square bracket, because it has the equal sign. Right. Next, a little bit more difficult. First, we require the x minus 3 inside an even root or a square root. So first of all, we have to have that x minus 3 have to be greater than 0. So that's the first thing. X minus 3 have to be greater than 0 or equal to, I'm sorry, because that's just inside an even root. And the second one is the whole thing, the square root. It is the denominator cannot equal to 0. So put those two together. We will have just x minus 3. It could be equal to, but actually it cannot. So we just have greater than 0. Because if we square both sides, we have x minus 3 not equal to 0. So we cannot have the equal sign here because it is the denominator. Right, so it is just greater than, cannot be equal to. By the way, this is a polynomial function, so the domain of this is all real numbers. Not going to worry about that. This is all we have here. Plus 3 on both sides. We have x greater than 3, and that's pretty much it. So it's going to be on the right side of 3. So just say it, 3 to infinity, and this one, it is no equal sign, so we have to use parentheses. So the difference of these two problems is that the square root of x minus 3 is at the denominator, so it cannot be equal to 0, it's just greater than. Right, there are two more here. This is the problem where we have the denominator cannot equal to 0. So we solve for x minus 1 on both sides. We have x squared not equal to negative 1, and then we take the square root on both sides. When we do that, always have to have the plus or minus. The problem with this is we have a negative inside an even root, so that is imaginary. So x different than imaginary numbers, meaning all the real numbers are acceptable. So we just say all real numbers. And we just write negative infinity to infinity. Next we have the natural log of x plus 3. That is the third rule we have. Inside the argument of the log must be positive. And subtract 3 on both sides. We have x greater than negative 3. And it is on the right side of negative 3, but not equal to. So that's what we have. Basically, the domain of some common function we have is denominator not equal to 0, inside an even root is greater than equal to 0, and argument of the log is positive. On this problem, we learn about the properties of a function and graphs. Pretty much what characteristic of a graph of a function. First, the x-intercept and the y-intercept. So for the x-intercept, it is on the x-axis, so y must be equal to 0. For the y-intercept, it is on the y-axis, so x must be equal to 0. So on the graph, we'll see that we have this point. It is on the y-axis, and so that is the y-intercept. The y-intercept is on the y-axis, therefore x must be equal to 0, and whatever the y value is the y-intercept in that case. So we have the y-intercept is 0 and 1. Next, the x-intercept. We have this point and this point. The x-intercept, in this case, there are two of them. It is on the x-axis, so y values must be 0. And this point is 1 for x and 3 for x. So we have two x-intercepts. Next, we have here the point 0 and 3. That is the y-intercept. X equal to 0, y equal to 3. and the x-intercept. The graph, let's assume that it goes through this point and keep going like that. So in that case, we have x-intercept here and there. X-intercept y must be equal to 0. So we have here is -2 and here x equal to 2. So those are the x-intercepts. The domain and range is the next part of the question. The domain and range. Domain is the set of all the x values. The range, the y values. So on this one, if we look at the x values, it has all the x values from -infinity up to this point and then continue on the way to infinity. So on this problem, we have the domain, all real numbers, and then the range. The range, we only have one y values here, that is -4. So we have to write -4. But when we write the domain or range, that's the set of numbers. So we just have one point of -4 for that part. For this part, we start from here, which is -2. I'm sorry, on the x, but on the y is the range. So we go from 1, go down to -2, and then pick it up on the way to infinity. So we know that on the right it's going to be infinity. And when we get to the lowest point, that will be -2. And that including the -2, so we use the square bracket. Let's put the union in between. So we have the isolated point -4, the y values, and -2 all the way to infinity. That is the range for the problem. X, the domain is all the x values, -infinity to infinity. For this problem, x values we have from this point -6 all the way to 2, and then we pick up from 2 again to infinity. So the domain will be from 6 to infinity, and because that is the dot, meaning it has to be including the 6, so that should be a square bracket. Range on the y values. The y values, we see that it is 3 for this line, and then it go down to 2, and then from here it go down to -2. Sorry, here it start 2 and go down to infinity. So all the possible y values will be from 3 down. So we're going to write the range. From 3 down to -infinity, so we have to write a smaller number first. -infinity up to 3, including the 3. So square bracket there. The next part of the question is about increasing or decreasing. Whenever we do this, we write the interval, and the interval here is more precisely must be an open interval of x. So an open interval of x, so we only write x values. So first let's look at where it is increasing. Increasing, it is where the function goes up. It is here, but we only write the x values. The x values is from 1 to 2. And the way we do that, we only define for an open interval. So where there is a dot on the empty circle is always parentheses. So that's the first part. The second part, we also have this, is the function going up from 5 to infinity. Notice that we're going to write just a comma in the middle and not a union. It should not be a union. Alright, decreasing is where the function goes down. So with that part, the x values will be -1 to 1. So whenever we write, we only write an open interval of x from -1 to 1. Yes, for that open interval. And then constant, where the graph goes horizontally. And this also an open interval from 2 to 5. Yeah. So 2 to 5. Again, it is an open interval of x. Next we have the graph. Based on the graph, we can say if it is even, odd, or neither. Even, the graph of an even function is symmetric on the y-axis. So just say y-axis symmetry. And then an odd function is the origin symmetry. And neither, of course, is neither of those symmetries. Right. So when we look at this graph, the first one, it doesn't have any symmetry. The symmetry actually is about here, which is not the y-axis. So this one, we just say it is neither odd nor even. This one, it is an even function because it is symmetric on the y-axis. Whatever point you have on the graph, go across the y-axis, we also have a point on the graph. So this is y-axis symmetry, therefore it is even. Right. Next, this one obviously is not y-axis symmetry. A point here go across the y-axis, there's nothing on the other side. So it is not y-axis symmetry. What we have is, if we go across the origin, there is a point on the graph. So if we have a point and we go across the origin, we have another point. So that is the origin symmetry. So that one is odd. And this one, a point here doesn't have anything on the other side. A point here doesn't have anything on the other side. So it's neither, because it has no symmetry. Notice that the symmetry has to be perfect for it to be even or odd. On this problem, we will determine if a function is even, odd, or neither using the definition, meaning algebraically. So by definition, an even function is where we substitute negative x into x, we will get back the original function. And the opposite, if we have an opposite to that, it is where we have an odd function. The difference, of course, is just this minus sign. There's some example to that. Is for an even function, pretty much anything that to an even function is going to be even. A constant is considered to be even, and absolute values of x is also even. Example of an odd function, there's not much. We just x to the odd power, and then an odd root of x, but that will be enough. Right. Now we use the definition to do this. The definition always starts with f of negative x, and that's where we start, f of negative x. So first, I will put negative x into x. replace negative x to x, and that's what we have. So negative x to an odd power, that's the green negative signs. So this will be negative 2 x cubed, negative and negative, that's the plus 5x plus 2. Now we compare this to the original function, and they're not the same because here we have 2x squared, negative 2x squared. So it is not the original function, meaning it is not even. Right. Next we test to see if it is odd. For odd we need the negative, so we will manufacture by factoring out a negative sign. So we have to have a negative sign there. And so that will be 2x cubed inside minus 5x minus 2. Now we compare this, the inside, with the original function. 2x cubed, that's good. Negative 5x, that's good. 2 and negative 2. That is not. So inside is not the original function. So this is not the original function inside the parentheses, meaning that it is not negative f of x. And because of that, it is not odd, meaning this function is neither odd nor even. Next, we have 2x squared plus 3. So as always, the definition, whether it's odd or even, we start with f of negative x. And that's exactly where we start with. We just need to replace negative x into x. So that would be 2x squared, because negative square, 2 negative sign become positive, and then plus 3. Compared to the original function, it is exactly the same as the original function. So this one is even. We could have a rational function like this as well. Still do the same thing. F of negative x. So we put negative x into x. Now when we look at this, we see at the bottom negative squared, so that would be positive x squared, so 2x squared plus 5. On the top we have 3 negative signs, and then 1 more, so it will be 4 negative signs, which turn to positive. Now obviously they're not the same, we're missing a negative sign. So because it is not equal to the original function, this one is not even. Next, we have to manufacture a negative sign. If we put the negative sign out, we're going to have negative 4x cubed, because when distribute the negative inside, that should be positive. So we have, when we factor out the negative sign, we have this. This is exactly the original function. So inside the parentheses or the bracket, this is the original function. So altogether, this is equal to f of negative x equal to negative f of x. So that's why this function is odd. And that's how we determine a function is even, odd, or neither, using the definition. Those are the definitions. On this question, we will use the graphing calculator to find the local maximum and the local minimum of this function on the interval of -2 to 2, and after that we determine where the function is increasing and where the function is decreasing. A few things about calculator. The most important button is going to be on the first row, and each one of them I write out what the windows will look like. And at any stage, if we want to get back to the home screen, it's going to be second and mode that will get back to the home screen. Alright, so first thing, of course, if we have the function that where we start with, click on the y equal to, and we're going to have this windows. We're going to enter the function that will be 3x to the 7 to the power 7 minus 3x to the 5th and then we graph will be this button. Right, so it is like that. Kind of difficult to see here. Also we only need to graph it from -2 to 2, so that's where we go to adjust the windows. The window button is the second button, and here we have x. We will change that to -2 to 2. Just put 2, and the scale we will set that, let's say, to 0.5, so meaning that will divide an sub-interval equal to 0.5. And also on the graph we see earlier, let's just click the graph and see, do we need to do anything else? So the graph is like this. We see the y values, it is very close to the x-axis, so we have to adjust the window, because from -2 to 2 here, there might be some minimum or maximum there, but we barely see it. So in that case, let's change the windows. Hit windows. The x values is good there, but let's change the window from -2 to 2 also. 2 and oops, sorry. So -2 to 2, and that says 0.5, and then we can graph. Notice that the window will go from -2 here and to 2 here. Look like we're going to have the minimum here and local maximum here, local minimum here. Then we just need to find it. So y equal to, enter the function, adjust the window if we need to. We'll get back to this in a minute. Now what we need to do is find the local max and local min. So if we hit, to get this to go to local max and min, we hit second, that button to calculate local minimum. So that's option number 3. And we hit enter. It will ask you what is the left bound. So when we try to find the local maximum or local minimum, let's say if we try to find this point, we need a little bit on the left of it, a little bit on the right of it, and then we can find the max and the min. So I will move, that point is fine, so I just hit enter, and we're going to move a little bit on the right and hit enter. Now you see that we will find the local minimum within this interval, so within this interval only. And when we hit enter one more time, the question asks us to guess, and we hit one more time, enter one more time, it will jump right into the minimum. So the minimum is at x negative 0.845. I'm going to write that down. Just maybe a little sketch. Local mean here is going to be equal to 0.845. Let's say 3 decimal places. Y is negative 369, so like 370. So that is the local mean. Now we do the similar thing for the local maximum. Second, calculate, and the maximum is option number 4. So the maximum is about here. So we need the left bound and the right bound. So we move a little bit to the left. Right. And as for the right bound, we go to the right. And when we guess, we will find the maximum in between this interval. And when we hit enter one more time, it will go right to the maximum, negative 0.845, and the y value is 0.3696. So let's say 0.370. We can easily see that this is an odd function, so we have the symmetry on the origin. Right. So local mean here, and this is local max. And we know it's bound from across. If we have the x-axis, this is negative 2 to 2. Right. The next part of the question is where the function is increasing. It will go from across negative 2 to that point. So we write increasing from negative 2 to that point. Notice that where we write increasing, it is only the interval of x, and it's always open, so we use the parentheses. And also increasing here. To 2. And decreasing, it is in the middle, negative 0.0845 to 0.845. Right. So we can find maximum and minimum, and after that we can find where the function is increasing, where the function is decreasing. The last thing though, we did change the window, so we need to change it back. To change it back, we hit the Windows key. Of course, we see that Windows. We need to change it back to the originally. So hit zoom, and the default option is zoom standard option number 6. So hit zoom and just hit number 6. It will go back to the original Windows from negative 10 to 10. And if we want to, we go to y equal to and hit clear. Now everything is clear as before. And to get back to the home screen, second mode. And everything is back to the original state. And that's how we use the calculator to find the maximum and minimum. On this video, we will find a polynomial function that has this characteristic. It is the 4th degree polynomial. We have these zeros, and we'll go through this point. So what we have is, first of all, we have the zeros. That's what we are given. Negative 1, 3, and negative 2. Degree of 4, meaning that we're going to have 4 zeros. That's why this is multiplicity of 2, so that is kind of important. Right, first, there's the theorem, the zero factor theorem. It says that if negative 1, if c is a 0, then x minus c is a factor. I'll write it out. X minus equal to c is a 0, then x minus c is a factor. Right, so negative 1, we're going to have x minus negative 1. Multiplicity of 2, meaning that we're going to have 2 of them. 3, so x minus 3 is a factor, and then negative 2, we have x minus negative 2 is a factor. I put them together, we're going to have x plus 1 squared, x minus 3, and x plus 2. So the polynomial that we're trying to find, we have to have those factors. But not just that. We might have a leading coefficient to be anything. We should write a4, but it's fine, a sub n, because this factor this coefficient does not affect the factor, therefore does not affect the zeros. So that is the polynomial we're trying to find. And now we just need to determine a sub n. Good thing that we are given this information here. So when x equal to 2, the whole function should be equal to 108. So we're going to have at x equal to 2, we still have a sub n here, but we know x equal to 2, so we have 2 plus 1 square, 2 minus 3, and 2 plus 2. And that's supposed to be equal to 108. And then when we multiply it out, that will be 3 squared will be 9 times 4, 36, negative 36. So I just write here. So this will be 9, negative 1, and 4. So altogether we will have negative 36 a sub n times that equal to 108. So a sub n is 108 divided by negative 36, which will be negative 3. So the polynomial we're trying to find will be negative 3, x plus 1 squared, x minus 3, and x plus 2. I just put negative 3 back into this. Right. Quickly though, if we need to evaluate this on the calculator, we can always bring up the calculator. Right, we can always do this. We put 2 and we store into x. I hit that key, store into x, and we will evaluate this. So I will write x plus 1. This problem is simple enough, we don't have to do this, but for more complicated problem, this might help. I forgot an x. and was just negative 36. We did that by hand also. And also we can also multiply this out, but let's not do that. So in this form we just have the polynomial, not in the standard form, but it will have all these properties. On this question, we are given a graph and we just need to find this information. So pretty straightforward. The first thing is find the domain and range. The domain is all the x values, the range is all the y values. We see that the x values can be anything except the negative 3, because that is going to be the vertical asymptote. So we said the domain, we're going to have x not equal to negative 3, or if we write in the interval notation, it is going to be negative infinity to negative 3 and negative 3 to infinity. So that is the domain. The range kind of similar all the possible y values, and the y values cannot be 1. So we can say range y is not equal to 1, meaning that we go from negative infinity to 1 and then from 1 to infinity. Right, so that is the domain and range. The x-intercept, we did this earlier. The x-intercept is where the point on the x-axis that intersect the point on the x-axis where the graph and the x-axis intersect. So it is this point here. Because it is on the x-axis, y must be equal to 0, and in particular x is going to be 2. Right. Next we find the horizontal asymptote. Horizontal asymptote is this line, and the equation for that line is y equal to 1. So horizontal equation is y equal to, and we just say y equal to 1, and that is the horizontal asymptote. The vertical asymptote is going to be this one. It's going to be x equal to, because that is the vertical line, and it is x equal to negative 3. And on this graph we do not have the slant asymptote or the oblique asymptote, so we're just going to say none for oblique asymptote. On this problem, we are given the function and we're asked to analyze the graph of that function. In order to graph it, we need to do this sub-problems first. The domain. First thing we see, the domain of a rational function is the denominator not equal to 0. So here we have x squared minus x minus 6 not equal to 0. We can factor as x minus 3 and x plus 2 not equal to 0. So we have x equal to 3 and x equal to negative 2, except that this is not equal to. Right, so that is the domain. We don't need to write that in the interval notation. Right. Next, for the vertical asymptote, we can just go ahead and do it, but potentially there might be something to simplify. So we'll see that the denominator will be factored as x minus 3 and x plus 2, and on the top we will have x minus 3 and x plus 1. Sorry, x minus 1. because we multiply it out and it should be negative 3. Right. X minus 3 cancel out, and we will have just x minus 1 and x plus 2. And notice that even though the function can be simplified like that, the domain is still x not equal to 3 and x not equal to negative 2. Those functions almost the same, except that here we can let x equal to 3, here we cannot let x equal to 3. The only thing is that. Only thing different are those two. And the vertical asymptote will be the same for either function. So we'll find the vertical asymptote. We will let the denominator equal to 0. In which case we just have x plus 2 equal to 0. And that gives us x equal to negative 2. And that's good. If we use the simplifying function, that will be it. One thing to note though, when we have x equal to 3 in this function, even though it's cancelled out, x equal to 3, if you put on the top and the bottom, we will have both of them equal to 0. So in the case where we have the bottom equal to 0 and the top also equal to 0, in that case we will have a hole on the graph. So the bottom equal to 0 and the top equal to 0 when x equal to 3. So we will have a hole on the graph at x equal to 3. We'll keep that in mind. The horizontal asymptote, this should be easy. The degree on top is the same as the degree at the bottom. Both of them equal to 2. Degree on top is 2, degree at the bottom is 2. So in that case, the horizontal asymptote will be equal to, the equation will be y equal to the ratio of leading coefficient. We just let 1 divided by 1. Coefficient of x squared is 1, coefficient of x squared is 1, 1 over 1 is 1. So we have horizontal asymptote, y equal to 1, and vertical asymptote at negative 2, a hole at 3. So we're going to use all of those information. So vertical asymptote at negative 2, and horizontal asymptote at 1. We know that when x equal to 3, that is a hole. So when x equal to 3, if we put that in here, 3 minus 1 over 3 plus 2, that's going to be 2/5. So when x equal to 3, it's going to be 2/5. So it's going to be this point. And when x equal to 0, this is very easy to check. When x equal to 0, we have no x here, no x there. We just have 3 over negative 6, so that's negative 1/2. So we're going to have negative 1/2 when here's the y-intercept. Right. So if we have those two, we can connect them and look like we have the graph. It's like this. They are home, and then continue. Right. Over here, we do need to choose some point though. So let's say when x equal to negative 4 or something, negative 4, negative 6, or anything less than negative 2. So I use calculator on this one, it will be faster. So if I put, for example, negative 4, Sorry, there's a problem with the calculator. Let me just reset that. Sorry, there's something wrong with the calculator. Oh, I think it's just slow. Right. So let's say we store -4 into x. -4 and store into x. And then we enter this function, x squared minus 4x plus 3 divided by x squared minus x minus 6 and that gives us 2.5. So when x equal to -4 we have 2.5, so it is about here, so we can see that the graph might look like this. Of course we can also put that in the graphing calculator, but we do need to find all of these details. Once again, the denominator not equal to 0, where we find the domain, it has to be from the original function. Everything after that we can use the reduce function, like the vertical asymptote, even the horizontal asymptote, we can use the reduce function. We do need to check for the hole on the graph is where both the top and the bottom equal to 0. Anyway, so that is we have the graph of the function. Again, those two functions will be almost the same, except the hole on the graph for that function. If we graph this function, it will be just continuous on that portion, and there will be no hole for this function. On this question, we just need to match the rational function to the graph. Actually, we are given the graphs, we just need to match the graphs to the rational function. So we will do this because we have the function already. We just do the process of elimination. So first, if we look at the first function here, what we see is the bottom is x squared plus 4. So if we let that equal to 0, we will not have any vertical asymptote. So this function will have no vertical asymptote. But moreover, if we find the horizontal asymptote for the first function here, we see that the degree on top is 1, degree at the bottom is 2. So where we have degree on top is less than degree at the bottom. That's where we have y equal to 0 as the horizontal asymptote. And we don't see any of that. Both of these asymptotes are not. This one we have the horizontal asymptote of y equal to 1. This one is y equal to 2 as the horizontal asymptote. So in that case, that function is not it. Right. We go to the second function though. On second function, degree on top is 2, degree at the bottom is 2. So on that one, degree on top equal to degree at the bottom, in which case we divide the leading coefficient and we have the horizontal asymptote of y equal to 2. So look like we might have this case here. Right, we'll get back to that. So this potentially will be, it's not going to be that, but it could be this one. I'll go to the next one. On this one, degree on top equal to the degree at the bottom. So the horizontal asymptote here, we just divide the leading coefficient will be equal to 1. So horizontal asymptote equal to 1. So that potentially be this one. Cannot be this one. Right. Next, on this one, when we try to find the horizontal asymptote, degree on top and degree at the bottom are the same of 2. Divide the leading coefficient, we have negative 1 over 1. So we have y equal to 1, negative 1. Because neither of this has the horizontal asymptote of negative 1. So this is not it. And then we go back to this. This has to have horizontal asymptote of 1. So C have to match to that. And this one has to have the horizontal asymptote of 2. So it have to be that. Of course, there will be other thing to test as well. Like this one, it has the y-intercept or x-intercept. This one, when x equal to 0, if you put 0 in here, we have 0 over negative 4, so that equal to 0. So we can also use the intercept to check this function along with the vertical or the horizontal asymptote. In here, strictly, we just use the horizontal asymptote. On this question, we have two functions, the function of volume in terms of radius and the function of radius in terms of time. So if we do the computation, we're going to have v of r of t, and that will be the function, the volume in terms of time. So pretty much the volume we start with is that. So we have 4 over 3 pi and then r cubed. So we're just going to put something cubed. Doesn't matter what it is inside. I just replace r with the parentheses. Now it turns out that r of t is going to be 1/3 t squared. So I'm going to substitute that in 1 over 3 t squared. So we will have 4 over 3 pi 1 over 3 cubed. So that cube will go to 1 over 3 and t squared also cubed. So we have 4 over 3 pi 1 over 3 cubed is 1 over 27, and t squared will be t to the 6th power. Multiply all of this, we will have 481 pi t to the 6th, and that is the combination of v and r, and put them together we have the function of the volume in terms of time, the volume in terms of time. On this question, we will find the inverse of this function, and after that we'll find the domain and range of the function and the inverse. To find the inverse of a function, a one-to-one function, we do this following steps. The first step is to replace f of x by y that is y. The next step is more important. We'll interchange x and y. So just x becomes y and y becomes x. Then we will solve for y. And to do this, first we get rid of the denominator by multiply both sides by 4y minus 5. And 4y minus 5 cancel with the denominator. And multiply this out. We have 4xy minus 5x equal to 2y. Both of them have y here. So we need to bring on one side. So I will minus 2y on both sides. And at the same time move the 5x to the other side by adding them. So we will have 4xy minus 2y equal to 5x. Since both of them have y, we can factor them out. Factor the y. We have 4x minus 2. And finally, to solve for y, we divide 4x minus 2 on both sides. We have y equal to 5x for x minus 2. The last step is just cosmetic. We replace y by the notation of the inverse. And we have that. And that is the inverse of the function. Next step, we will find the domain and range of the function and the inverse. To do that, first we do need to check to make sure that we actually find the function, do it correctly. So first, let's zoom out a little bit, and then bring the calculator up. Right. First, we will graph the function and then the inverse. So if I graph 2x divided by 4x minus 5, and we see the graph. Right, so that we will graph the inverse later, but now since we see that, we should write the domain and range. As we see on the graph, the domain on the x values will be all real number except for where there is the vertical asymptote. We could see that the vertical asymptote is at where x equal to 5 over 4. So to find the vertical asymptote of this function, we let the denominator equal to 0, and we have 5 over 4. So we write that because the vertical asymptote is equal to 5 over 4. Right. We should write as the interval notation. Next, the range. We see that the graph of the function, again this is the function, we have all the y values except for the horizontal asymptote. The horizontal asymptote for this function, since degree on top and degree at the bottom are the same, we divide the coefficient. So that could be 2 over 4, which will be 1/2. And y not equal to that. It's not the reason, but just note that the horizontal asymptote is 1/2, because the graph may still intersect the horizontal asymptote, but not on this problem. On this problem, 1/2 is the horizontal asymptote and the graph does not intersect it. And we will write this in interval notation. Everything but 1/2. Right. So that we have the domain and the range of the function. Now we'll graph the inverse. The inverse is 5x divided by 4x minus 2 and we'll see the graph. Now kind of difficult to see, but the graph of the function will be symmetric on the line y equal to x. So let me add the line y equal to x. And let make that a dotted line. So we see that the two functions actually symmetric on the line y equal to x. So that is the properties of the inverse. And so the function we found is correct. And also we can see that the vertical asymptote of the function is the horizontal asymptote of the inverse. The horizontal asymptote of the function will be the vertical asymptote of the inverse. And then properties of the domain and range for the function and the inverse. Finally, we can write domain of the function equal to the range of the inverse. And we don't need the calculator anymore. That is because we interchange x and y, so the domain and the range also interchange. So domain of the function, the range of the inverse will be this. And the range of the function and the domain of the inverse will be equal to this. and that's how we find the inverse of the function, and then use these properties to find the domain and range of the function and the inverse. This problem is straightforward. We have the equation that model the spread of a rumor, and P is the population, and in this case is 1,000. So pretty much we will have N equal to 1,000, 1 minus E to the negative 0.15 D, and where D is the number of days. So the question asks us how many students will have heard the rumor after 3 days. So pretty much we will let D equal to 3, and then we find the values of the function. So we need a calculator for this. So we have 1,000. Oops. Multiply 1 minus E, that will be second, and ln negative. Notice that we use this negative sign and not the subtract sign. 0.15 times 3, and let's close the parentheses and hit enter. We have 362.37. Since that is the number of people, we'll round it up, 363. Right. Next, how many students will have heard the rumors after 10 days? So when D equal to 10. Right. We can enter the same function, the same thing, but if we hit second and enter, we have the last entry, or usually if we can just go up and highlight that, and when we hit enter it will copy and paste to the line. All we need to change is change the 3 to 10, and we have it. Again, we'll round up to 777. And when D goes to infinity, we see that this function will go to 0, and so indefinitely, essentially all 1,000 of those students will hear the rumor. Anyway, so this question is pretty straightforward, and we use the calculator to find the values of the function. On this problem, we are asked to graph this function, and then after that, find the inverse, and then graph the inverse. So first, what we see is the basic function is ln of x on natural log of x. Just like any log, the graph of a log function in general will go to the point 1 and 0, and it has the vertical asymptote as the x-axis. I mean y-axis, x equal to 0. So this is the vertical asymptote, x equal to 0. And the graph will go like that. So that's the graph of the log, or in this case ln of x, or the natural log of x. And then we have the plus 1 to it. So pretty much this graph will shift 1 unit up. So this point will go up there. The vertical asymptote go up 1 unit, so we still have the same line. So the graph will go just like that. Everything will go up 1 unit. So the point 1 and 0 go up 1 unit. The vertical asymptote go up 1 unit. Still the same line. Right. And from the graph of the function, we can find the domain and then the range. Actually, we sketch the graph first. Right. The domain. In general, this refer back to the first question of this review. Whatever we have inside the log have to be positive. The log of any base, logarithm of any base, the argument must be positive. So we just have x greater than 0, or we write the domain is from 0 to infinity, not including 0. So we that. Sketch the graph. Already did that. Find the range. When we look at the range, the vertical asymptote, so it get up close to the line, but we never touch. So this will keep going down to negative infinity and keep going up to infinity. So the range negative infinity to infinity. And so that is the domain for the function, the range for the function. And this is the graph. Next we'll find the inverse, and then find the domain and the range of the inverse, and then sketch the inverse. So we don't even need to know what is the inverse. We can answer this part first, the domain and range. So we use that properties. The domain of the function is the range of the inverse. And the range of the function is the domain of the inverse. And from the first part, the domain is from 0 to infinity. And the range of the function is negative infinity to infinity, so that will be the domain of the inverse. Yeah, this problem where we plus 1 unit up, the range doesn't affect anything. So domain of the function, range of the inverse, is 0 to infinity. The range of the function, domain of the inverse, negative infinity to infinity. Now we find the inverse. When we find the inverse, there will be 4 steps of the problem. So let me write the function first. So the first thing we do is replace the function by y, and then interchange x and y. So y becomes x and x becomes y. And after that, we just need to get solve for y. To solve for y, we subtract 1 on both sides. So have x minus 1 equal to ln of y. and then to solve for y, raise both sides to the power of base e, because we have these properties. E to the ln of x, e and ln can cancel out, so that's just x. Same thing here, e and ln, here we simplify, and we have y equal to e to the x minus 1. And so that is the inverse. And we use the notation for the inverse. Instead of y, we write inverse is equal to e to the x minus 1. Right, now we're going to graph this function. So first, e to the x, we go to the point 0 and 1. So that is e to the x. And we have minus 1 on the x, so everything will go to the right 1 unit. So this point go to 1 unit to the right. And also for the exponential function, we have the horizontal asymptote. Y equal to 0, this line. And that line goes 1 unit to the right, so it's still the same line. So the graph will go like this. Right, so that is the inverse. So we have that. Just one more thing though. If we're going to graph the inverse and the function on the same coordinate system, I'm going to do that in pencil here. Go to the point 1 and 1. That the exponential function, the inverse e to the x minus 1, and it is symmetric on the line y equal to x. As you see, it is the mirror image of each other. So the graph of ln of x, or any log of any base, will be like that. Go to the point 0 and 1. This one go 1 unit up, and we have that. When we're trying to find the inverse, interchange x and y, and then solve for y, we have the inverse. And the domain of the function is the range of the inverse. The range of the function is the domain of the inverse. And then we have the graph, exponential function. That goes 1 unit to the right. On this problem, we only need to solve for y in terms of x. And similar to the last problem, we have e to the ln of x equal to x, so e and ln cancel out in that sense. So in that case, we raise both sides to the power of e, the natural base. So we'll have in an ln cancel out, we just have, let me just write that. Have this, and then e 3x plus ln of c. C is just a positive constant. Right. And as mentioned before, that will be just y minus 5. Now, it is exponential e raised to something plus something. So we have the same base that we have, say, m plus n that will be equal to b to the m times b to the n. So we have a plus here. We will turn to a product. And similar to the first part, I'll cancel that. So we have y minus 5 equal to e to the 3x, and that will be just multiplied by c. Now it's better to write as c, the constant, times e to the 3x. Like that is that. And since we solve for y, just need to add 5 on both sides. And that's what we have. On this question, we will solve this equation using graphing calculator. So all we need to do is just graph those two functions and then find the intersection of them. So on the calculator, just enter those two functions. E to the x for the first one and negative x for the second function. Now we just need to find the intersection. Again, y equal to, and then we enter the function. If we want to see the graph, that is the graph, and we see the intersection will be somewhere in there. Alright, now when we find the intersection, all we need to do is hit the second and the trace button and go to option number 5. That will be for the intersection, and they ask for the first curve, which is this function, which is good, so just hit enter. The second curve is negative x, which is also good, just hit enter again. Guess, if we want to guess the solution, we can move along the second function. When we get close to the solution, we just hit enter, and it will jump right into it, and we'll see that the intersection is x equal to negative 0.5 something. Just write 3 decimal places. On this problem, we will find trigonometric function for some given condition. We have 2 problems. This one, the first one, and then that. Before we do it, let's go over all the trigonometric ratio, sine, cosine, tangent. Sine is y over r, cosine is x over r, tangent is y over x. And then we have the reciprocal of those functions. Cosecant, reciprocal of sine. Secant, reciprocal of cosine. And cotangent, reciprocal of tangent. And now we given this condition, right? So sine is equal to negative 1 over 5. And the ratio for sine is y over r. And r is, we define let r always be positive, so we can let r equal to 5 and y equal to -1. So from there we have r equal to 5 and y equal to -1. Right? And after that we can find x. Pythagorean theorem, x squared plus y squared equal to r squared. So we have x squared plus r, y squared will be -1 squared equal to 5 squared. We have x squared equal to 24. So x equal to plus or minus square root of 24. There are plus or minus. We need to determine if it is a plus or if it is a minus. So go back to the problem. We see that we are given tangent is less than 0. Tangent is y over x. So if y over x is less than 0, and we know that y is negative. And because of that, x must be positive. Because the ratio y over x is less than 0, so one of them is positive and one of them is negative. So x is positive. So we're going to choose positive. Square root of 24. Just 24 or square root of 4 times square root of 6. Which is 2 square root of 6. Right. Now we have x ready and r and y. We can put back here in this ratio and we have the answer. So y over r, of course that one is given already, it's negative 1/5. Cosine x over r, 2 square root of 6 over 5. And y over x is tangent y over x. So we have -1, 2 square root of 6. We could multiply square root of 6 top and bottom, but I'm okay with the answer like that. R over y, r is 5, and y is -1. This is -5. R over x, r is 5, x is that, and I will just keep it like that. And then cotangent x over y, x over y, so 2 square root of 6 over -1 be -2 square root of 6. And that will be the first part of this question. Next we go to a similar type question, but we are given different condition. Again, I will write all the ratio again. Sine is y over r, cosine x over r, tangent y over x, cosecant r over y, secant r over x, and cotangent x over y. Those are reciprocal, and reciprocal. Right, let's go with the condition. We are given that tangent is equal to 3 over 4. And tangent we have is y over x. Right. It's very tempting to say that y is 3 and x is 4 and we're done with that. But notice that we have this condition as well. cosine is negative. Cosine is x over r, and it is negative. We know that we will let r be positive always, and because of that, x must be negative. Because the ratio is negative, one of them is negative, the other one is positive. So x is negative here. Now, if x is negative, y also have to be negative because the ratio is positive. So both x and y must have the same sign. So one is negative, the other must be negative as well. So from that, we say x is negative 4 and y is negative 3. Right? And then Pythagorean theorem, x squared plus y squared equal to r squared. Negative 3 squared, negative 4 squared. So that is 9 and 16. So 25 is r squared. So we have r is equal to plus or minus square root of 25 or plus or minus 5. But the way we define it are always positive. So we just use 5. So with that we have r is equal to positive 5. So we have r, x, and y. Put it back in the ratio, and that will be it. Sine is y over r, negative 3 over 5. Cosine is x over r, negative 4 over 5. Tangent, this one is given. And reciprocal of that, cosecant r over y, 5 over negative 3 or negative 5 terms. R over x is secant so pretty much we need to find x, y, and r. Once we know them, we should know all the trig ratio. On this problem, we are asked to find a computation function between an inverse and a function in that order. Before we do anything else, we notice that sine is the ratio of y over r. If we let r equal to 1, then sine is just y. So on the unit circle, y is sine of theta. Now, next, we will find the range of the sine inverse, or the domain of, the range of the sine inverse. First of all, the sine inverse will give us the angle. On the trig function, we have the first quadrant. So we always have the first quadrant on the trig function. And then we have to pick one more quadrant for the sine inverse because it is associated to the y values. If we're going to pick this quadrant, this is not going to have the different y values. So we have to pick this quadrant so the y values will be different for every point on that. So the domain of, I should say the range of the sine inverse, we go from negative pi over 2 to pi over 2. So being that values. Next, sine of 11 pi over 8. So 11 pi over 8, we just do 11 over 8. It is 1.375. Let me check. Yes, so about 1.375. So this is 0 pi, half a pi, pi, and 3 pi over 2. So 11 pi over 8 is about here. So we just say it's about here. So we go from half a pi, pi, 11 pi over 8. Right. So if this is the point, the sign will give us the y values. So the y values is right here. So that we can say this is sine of 11 pi over 8. This distance. But when we try to find the inverse of that values, it has to be in this arc. So the answer is going to be it at this point. And so if we know that if it goes all the way around, to here is 11 pi over 8. We need to find that angle, which is going to be our answer. So if this is 11 pi over 8 is that much. So notice that if we go from here to here, this point, that would be a pi over 8. Pi always have a pi over 8. So the remaining here is going to be 3 pi over 8. So this part here is 3 pi over 8. Because of that, this is going to be negative 3 pi over 8 because it goes clockwise. So when we do this, it's going to be negative 3 pi over 8. Again, we try to find the sine, which is the y values, and then find the inverse in equivalent range. So it will be negative 3 pi over 8. Right. Next. Next, we have the cosine inverse of cosine of 7 pi over 4. So first thing we do is find the domain, I should say the range of the inverse cosine. As always, we pick the first quadrant. So on the trig function, we have the inverse, the range on the first quadrant. Next, this is cosine inverse. Or for cosine, it is x over r. And so if we let r equal to 1, cosine is equal to x. So on the unit circle, cosine is x, or x is cosine. If we choose this arc, then this is good because all the x values are different. If we choose this arc, all of the point here and the point here will have the same x values. So we cannot have that. We have to choose another quadrant other than the first quadrant, so that all the x values, every x values is different. Some positive, some negative. If we choose the point down here, those have the same x values. It doesn't work. So we have the range of the inverse cosine go from 0 to pi. Right. Next, we do cosine of 7 pi over 4. 7 over 4 is 1.75. So that will be right in the middle here. And that is 7 pi. Sorry, we go from here. 7 pi over 4. And we are asked to find, we go from here now. So we have this point. This point and cosine is the x value, so we project to have the x values here. So this length is going to be cosine of 7 pi over 4. Cosine of 7 pi over 4 is going to be this. Now all we need to do is project that into the arc and find the angle. So we need to find this angle so that we're going to have the same x values. So the answer is going to be this quadrant. This answer, this angle here. So notice that this is 7 pi over 4. So we need to go pi over 4 more to complete 2 pi or 1 revolution. So if this go pi over 4, this also pi over 4. So the answer is going to be just pi over 4. So for this one, we just need to find either the x or the y values inside and then find the angle equivalent to that. Have to be very careful with the range of the sine inverse and the cosine inverse. So we have to make sure it is in the correct quadrant. In this problem, we will find the computation of a function and the inverse. First, the inverse will give us an angle, so we will let this equal to theta. That's where we start. Next, we take the cosine on both sides. So cosine on both sides. That gives us a u. We then draw a little triangle, right triangle. Let theta be that acute angle. Cosine of something is adjacent over hypotenuse. And in previous ratio we have u. Why don't we write u over 1? So we match u is adjacent, 1 is hypotenuse. So adjacent is going to be u and hypotenuse is 1. From that we can find this length is square root of 1 minus u squared. We usually just check the positive values. Next, the question answers for the cotangent of cosine inverse u. Cosine inverse of u is theta, so we just have that. And cotangent is reciprocal of tangent, so we have adjacent over opposite. Adjacent is u and opposite is square root of 1 minus u squared. So that is that. Next, we have this one will be similar to that. First, we will let inside the tangent inverse will give us an angle theta. So let theta be the tangent inverse of u. And then we will take the tangent on both sides because tangent of tangent inverse, it can cancel tangent inverse. we just u, or we write u over 1. And then we draw a triangle. Tangent is opposite over adjacent. So we will let that equal to u and 1. So opposite is u, adjacent is 1. So hypotenuse will be 1 square plus u square, or just 1 plus u square. And then next, sine of tangent inverse of u is just sine of theta, and sine is opposite over hypotenuse. Opposite is u, hypotenuse is 1 plus u squared. So that's what we have. So we'll let the inverse equal to an angle, and then find the ratio, find the opposite, adjacent, and hypotenuse on the right triangle. Once we know those, we know all the trig function, all the trig ratio. This is sine, so opposite over hypotenuse. Opposite is u, hypotenuse is 1 plus u squared. So that's what we have. On this question, we have a couple of problems about trigonometric equation, one with the cosine, one with sine. Right. So whether it's cosine or sine, we just need to get that function by itself first. So I will minus, add square root of 3 on both sides. And then divide by 2. So we should have cosine theta square root of 3 over 2. And then we just find theta. Now let's just take a look at the unit circle real quick. Cosine is associated to the x values. So we have x is about square root of 3 over 2. So that's more than 1/2. So we're going to have this point. Square root of 3 over 2 is that point. Then we have an angle here. So that will be 30, 60, 90 degree right triangle here. So theta can be equal to, that would be pi over 6. And then we will have another angle here. Because when we go around, we get back to this point where we have the same x values. So if this is pi over 6, this is negative pi over 6. And we take 2 pi away from it. So we say all theta could be equal to, I will do 2 pi, the whole revolution minus the pi over 6. And that gives us 12 pi over 6 minus 1, so it will be 11 pi over 6. And those are the two solutions within 0 and 2 pi. So that's the first one. The second one is where we have 4 sine of theta minus pi over 3 plus 2 equal to 0. So first we will get the sine function by itself, and then we find the angle. So we minus 2 on both sides. and then we divide by 4. And sine of theta minus pi over 3 is negative 1/2. And again, we draw the little unit circle. The sine function is associated to the y values, so negative 1/2, kind of halfway there. Right. And for that, we're going to have two values here that have the same y values of negative 1/2. And if we go from 0, then we will go all the way to here. That's the first values. And the second values is in this direction. Right. Now, if this is 1/2, then this is going to be pi over 6. Pi over 6 is this angle here, plus a pi, we have 7 pi over 6. Pi over 6, that first angle here. And if we go a little more to this point, to this terminal ray, they also have the same y values. So notice that if that is pi over 6, that little angle here, and so this angle would be 11 pi over 6. I mean, this also pi over 6, and the red angle is 11 pi over 6. And then to solve for theta, we just add pi over 3 on both sides. So theta 7 pi over 6 plus pi over 3. If we use the calculator, then we pretty much ignore the pi and we just add the numbers and then we put the pi back to it. And by that I mean we have 7 over 6 plus 1 over 3. Just ignore the pi. We have 1.5 can turn to fraction. That will be 3 pi over 2. Next we have 11 over 6. And we're going to add pi over 3 both sides. And we have 13 over 6 pi. I said we just stick a pi to it. The only problem here is the theta has to be between 0 and 2 pi, and this is way more than that. So what we do is we have to subtract 2 pi from it, because that is more than 2 pi. When we subtract 2 pi from it, we just have pi over 6. So that is the answer, 3 pi over 2, then pi over 6. And notice that the cosine, we have the same cosine, we use the x values, and sine we use the y values. And when we use the calculator, we just add the numbers and then put the pi there at the end. We have an application problem here where we just need to solve trigonometry equation. So first, if we read the prompt, the pressures will be P, and the first one is going to be 100. So we have 100 equal to P, and we have 100 plus 30 sine of 9 pi over 4 t. Cancel 100 on both sides. We have 0 equal to 30 sine of 9 pi over 4t. Divide both sides by 30. We will have 0 equal to sine of 9 pi over 4t. Right. So we look at a unit circle. A sine values. A sine is equivalent to the y values. The y values equal to 0. We will have sine equal to 0 is the y equal to 0. So we have this point and that point. So we can say 9 pi over 4 t equal to 0. Have to add to n pi because the period of sine is 2 pi, and we might have coterminal angles. Or we have 9 pi over 4 t equal to pi plus 2n pi, right? Multiply both sides by 9 pi, divide both sides by 9 pi over 4, we have t equal to, that's still 0. We need a calculator for this problem. So we will take 2 and then divide it by 9 over 4. That will be a over 9. With the pi cancel both sides, so we have a over 9. N will still be there. Pretty much that. And on this side we divide, we will have t equal to pi cancel, we have 4 over 9. And 2n pi divided by that, we will still have a over 9 times n. Now we do some values for n. If n equal to 0, t equal to 0. When n equal to 1, we have t equal to a over 9. If we choose high values for n, it will be outside of the 0 and 1. So we only have 2 answers there. We have one more here. When n equal to 0, t is 4 over 9. If we choose higher values of n, the answer will not be between 0 and 1. So we have 3 answers here. Don't worry, there's a way we can check it later. Next, we're going to have 130, and we're going to put that in for p of t. So we have 130 equal to 100 plus 30 sine of 9 pi over 4 t. Minus 100 on both sides. We have 30 equal to sine, I forgot the 30, sine of 9 pi over 4 t. Cancel 30 on both sides. 1 equal to sine of 9 pi over 4 t. Again, we go to the unit circle. Sine is the y values. The y values equal to 1. It has to be y values equal to 1. So we only have one possible answer is pi over 2. So we'll write the angle here, 9 pi over 4 t has to be equal to pi over 2. Of course, it potentially be more than one answer, so we have 2 n pi here. Next, we divide by 9 pi over 4 on both sides. This we know that's going to be 8 over 9 pi. I mean 8 over 9 n, sorry. And pi over 2 divided by 9 over 4. So we just use a fraction of 1/2 divided by 9 over 4. And we have 2 over 9. As we see, we can only choose one values for n, because if n is equal to 1, we will have the answer outside of 0 and 1. So we only have one answer there. Right. Next, we asked to find determinant with the pressure of the fluid between 100 and 105. We have to use a calculator on this one. Right. So first, let's plot the function. Just make sure that it has to be in the radian mode. It is. So it's good. Second in mode. We enter the function 100 plus 30 sine of, we can use alpha y equal to get the fraction. If your calculator can do that. If not, we just sorry, it's difficult to use a calculator with a mouse. Sine of 9 pi let's put x instead of t divided by 4. Right, and we hit graph. Of course, we should not see anything because the graph, it is between 100 and it go up and down, 30 unit up, 30 unit down. So we should change the windows. The x values only go from 0 to 1. So we say x is go from 0. Let's just say 1. Let the increment be 0.1. The y values, the minimum 100 minus 30. So we just say 65 would be good. Go to 135. And let's say the scale of 10. When we hit the graph, we should see it. We can put 100 for one function, and then the other one is 105. And then when we graph, you see that there will be 3 answers where it is equal to 100, and then 3 more when it is equal to 105. Right. So pretty much we find this interval here, and that interval there. So quickly, let's sketch the graph. We have something like this. That is 100. And then we have 105. So the answer, we only have this part of the graph. We know the first one, it is going to be equal to 0. The first point here, I just need to find that x values, so that will be we will have the interval right there, and interval here, and an interval here. I'll just do one. Right, pretty much we'll try to find the intersection right there. So we hit second, calculate. Option number 5. The first curve is the first function. That's what function we want. y2 is not 100, so we have to go down, and the second function is 105. That's what we want. Hit enter, and then when we guess, we just move the pointer close to the solution we want. It have to be all the way here. Close enough. When we hit enter, we will jump right into it, and we have 0.024. So we have the first interval of 0 and 0.024, and then we can find the rest of the problem. There will be 3 more. And that's how we find intersection using the calculator. If for a special case when the number is nice, we can do it by hand. But if the number is not nice, we have to use the calculator. We just have a couple problems proving identity here. So usually when we try to prove a trig identity, we work for a more complicated sign and then simplify it. So we start from the left hand side here. So I just multiply it out. 1 times 1 minus cosecant plus cosecant minus cosecant square, right? And I cancel the cosecant on both sides. So we have 1 minus cosecant square. Right. So we have that. Take a look on the right hand side, we have cotangent, negative cotangent square. So somehow there's a formula related cotangent square and cosecant square. And they are, which is cotangent square plus 1 is cosecant square. So we will have, if we want to find that, so we just minus the cosecant square on this side and the minus cotangent square on both sides. And then the minus cosecant square on both sides. And when we do that, we should have 1 minus cosecant square equal to negative cotangent square, which is exactly what we have, which is the right hand side we're trying to prove. So this is just a little algebra and the trick the Pythagorean identity. The next one is a little more complicated. As you see, the left hand side is a fraction, a little more complicated. So again, we start from the complicated sign, so that's the left-hand side. And so we start from the left-hand side, and this is what we have. And to combine this, we use the least common denominator. Just write out. I multiply that top and bottom. Right. So we need to have that at the denominator. So we will multiply 1 minus cosine theta. And we do that on the top as well. For this one, we only need the sine theta. So we multiply that on the top. Right. Now we have the common denominator. And then on the top, we will have this. So I combine the top, multiply it out. 1 minus cosine theta minus cosine theta plus cosine square. And this will be just sine square. Now we know cosine square plus sine square is equal to 1. So we will have sine theta and 1 minus cosine theta at the bottom. On the top we have 1 plus 1 will be 2 minus cosine, that will be 2 cosine theta. Now both of them have 2, so we can factor out 2. And we have 1 minus cosine theta. And we can simplify the 1 minus cosine. So we just have 2 over sine theta. Reciprocal of sine will be cosecant. And that is the right hand side. And we prove what we asked to prove. From left hand side, simplify to the right hand side. On this problem, we are asked to prove these identities. We have sine of a sum and cosine of a difference. So where there's sum or difference, let's just go over the identity first. So we have sine. Let's say two angles U and V. Start with plus. So for sine, the sign in the middle is going to be the same, so the middle is going to be a plus. But the function is going to be different. So we have sine of U, cosine of V, and then cosine of U, sine of V. So that is a plus. You see the sign in the middle will be the same, the function opposite, difference. One is sine, one is cosine. If we have the minus or the subtract, we have to subtract. Right, so that is sine. Cosine, let's do a plus. The sign in the middle will be opposite. If that is a plus, this will be a minus. But the function will be the same function. We start with cosine and cosine, sine and sine. If there's a minus in the middle, we're going to have a plus. Right. Sine, we have the same signs. Cosine is opposite. For sine, we have different function. Cosine, we have the same function. Right. And with that, this problem will be pretty simple. We start from the left hand side. Is equal to sine pi cosine theta minus, the plus, the sign should be the same for sine. Cosine of pi, sine of theta. Sine of pi is 0, cosine pi is -1. So this pretty much equal to negative sine theta. Next we will do similar problem, but this time we have a cosine of a difference. Cosine, we use the same function. The sign in the middle is opposite. Cosine pi over 2 is 0, and sine pi over 2 is 1. So that cancels out, we just have sine of theta. On this problem, we will have another trigonometric equation. The only thing different here is we have cosine of 2 theta, so we have to start with that. Cosine of 2 theta equal to cosine square of theta minus sine square. We can also write 2 cosine square minus 1 and 1 minus 2 sine square. Right. But since we have cosine on the right hand side of the equation, we're going to use 2 cosine minus 1, and we substitute into cosine of 2 theta here. So do that, we will have 2 cosine square minus 1. That will be the cosine of 2 theta. We still have 9 in front. Minus 27 cosine theta minus 18. Multiply it out, and then we move everything on one side. Now we move everything on one side. So we will have 18 cosine square plus 27 cosine theta, and then plus 9 equal to 0. All of this divisible by 9, so we divide everything by 9. So we have 2 cosine squared plus 3 cosine theta plus 1 equal to 0. And this is a quadratic equation or in form of a quadratic form. So we can factor. I just split this into 2 cosine theta and factor by grouping. Both of them have 2 and cosine, so I factor it out. We have cosine plus 1 left. And both of them have cosine plus 1, so factor it out one more time. We have this. So product is equal to 0. At least one of them is 0. So we'll have divide this into 2. On one side we have cosine theta plus 1 equal to 0. The other side 2 cosine of theta plus 1 equal to 0. Now this gives us cosine is equal to negative 1. And this gives us cosine equal to negative 1/2. Now if we look on the unit circle, cosine again is the x values. The x values is equal to negative 1, where we have this point, which is at pi. And in the whole unit circle, that is the only point that gives you cosine of that angle equal to negative 1. Now we go to the other. Again, cosine is the x values, it is negative 1/2. So we will have 2 angle that corresponding to negative 1/2. The x values of negative 1/2. So one of them is this angle, and the other one is that angle. So the first one we can see that is going to be 2 pi over 3, and this one will be 4 pi over 3. And in from 0 to 2 pi, those are the only answer we have. So we have pi, 2 pi over 3, and 4 pi over 3. Let me zoom out so you'll see the whole problem. So when we see the multiple angle, and I mean different on both of them, one with just cosine, one with cosine 2 theta, we have to rewrite. So in that case, we only have one of the type of the angle. In this case, just cosine theta. And the trig identity that we use this one. And once we have quadratic equation, we can solve for it. And then at the end, it's just simple trigonometric equation. And that's what we have. Here we have another trigonometric equation dealing with multiple angle. We have sine 2 theta here and sine 4 theta there. Somehow we have to write that in terms of only one type of multiple angle. So we will have to rewrite the sine of 4 theta sine 4 theta, we can write sine of 2 times 2 theta. And the double angle give us 2 sine 2 theta cosine of 2 theta. And that's the only formula we have. Of course, that will substitute in sine of 4 theta. So we will have sine of 2 theta. We usually don't need the parentheses for that. Minus 2 sine 2 theta cosine 2 theta equal to 0. Now both of them have sine of 2 theta in common. So I will factor it out. Then we will have 1 minus 2 cosine of 2 theta equal to 0. Again, we have a product equal to 0. So one of the factor must be 0. So if we have sine of 2 theta equal to 0, then all we have 1 minus 2 cosine 2 theta equal to 0. This will give us cosine of 2 theta equal to 1/2. Right. Now we just solve the trigonometric equation, both of them. This is a little more complicated because we have the multiple of an angle. So first, sine of anything is associated to the y values. The y values equal to 0 must be here or here. However, we have to write the answer in terms of coterminal angles. So either it's going to be 0 plus 2n pi we should write 2 theta because that is the whole angle of that function. Or we have 2 theta equal to pi plus 2n pi. And we're going to work both equations in tandem. If we divide everything by 2, the first part we have theta equal to, divide by 2 we have theta, divide by 2 we still have 0, divide by 2 we have n pi. So that's one of them. The second part, we have theta. If we divide by 2, pi over 2 plus n pi. Right. Now we choose some values for n. Now if we let n equal to 0, theta will be equal to 0. The first one, theta here will equal to pi over 2. Both of them between 0 and 2 pi, so it is good. Then we choose n equal to 1. If n equal to 1, put 1 here, we have theta equal to pi, which is good because that's still between 0 and 2 pi. And then if we choose n equal to 1, here we have pi over 2 plus pi, which is 3 pi over 2. Then if we choose n equal to 2, that will give us 2 pi, which is not in that domain, so that doesn't work. And then that plus 2 pi, that also bigger than 2 pi, so that doesn't work. So those are all the solutions we have for that part. There are 4 of them on this side. Now we go to the other side. cosine is equal to cosine of an angle equivalent to the x values. The x values of 1/2 will be right here. So associated to that we have two angles. One is here, which is pi over 2, pi over 3, or we can go all the way here. Give us, if this is pi over 3, then we have minus pi over 3, and add 2 pi to it, we have 5 pi over 3. So we have two answers here. 2 theta equal to pi over 3. Just write like this one. 2 theta equal to pi over 3 plus 2n pi. The 2n pi is the period. 2 pi is the period of cosine or sine. So we can have the coterminal or period more than just the answer itself. So 2 like that. I just copy it, but right. Now we divide everything by 2. The pi over 6 plus n pi, 5 pi over 6 plus n pi. And then we choose some value for n. At n equal to 0, n equal to 0, we have pi over 3, pi over 6. Just like theta equal to pi over 6. And on that side, we have 5 pi over 6. If n equal to 0, now n equal to 1, we have pi over 6 plus 1 pi. So that would be 7 pi over 6. Still between 0 and 2 pi. Still between 0 and 2 pi. And then on that side, we have 5 pi over 6 plus pi is 11 pi over 6. And then when we choose n equal to 2, we don't need to do that, but when we have 2 here, that will be more than 2 pi. And here, the whole thing is more than 2 pi. So it's not going to work if n is bigger than 2. So we have the solution, those 4 solutions. And then this 4, 2 more here. And then actually 2 more here. That should be 8 answer. Like that. So we just rewrite the sine of 4 theta using double angle of sine, and then we factor. Each factor must, at least one factor must be 0, and we let that equal to 0, and we solve for it. When we have the multiple angle equal to something, at the end we can divide back, and we just have the angle by itself, the theta by itself, and then we solve for that. Make sure we have to choose some values for n, so that the answer will be between 0 and 2 pi. If we choose n too big, it will not be within 0 and 2 pi. And that is how we do that problem. On this problem, we will try to simplify this into only single trigonometric function of power 1. Right. So first we see we only need to reduce this. So that looks like the cosine square, like cosine 2 theta, like we did before. So I write that formula, cosine of 2 theta, on this case, let's say 2x is equal to cosine square minus sine square, or we can use this formula 2 cosine square minus 1, or 1 minus 2 sine square, and that is close to what we're looking for. We still have the 2x here. Alright, so that's good and all. We still can use that. This is sine square of 2x though. So pretty much if we double this angle, so that will replace into cosine of 4x, and will be the same thing, 1 minus 2 sine. Now we're going to double this angle, and that's what we have. So we still can use this. So we have 1 minus 2 sine square of 2x will be cosine of 4x. So what we have is 4 sine 2x cosine 2x. I need to copy the original problem. Right. Now let's just rewrite. We have sine 2x and cosine 2x. That look like the double angle of sine. So instead of 4, write 2 times 2 sine 2x cosine 2x, 1 minus 2 sine square 2x. Right. Earlier we see that this is going to be 1 minus 2. Those two are the same thing, so will be cosine of 4x. So that will be cosine of 4x. And the double angle of sine, I'm going to write over here, sine of 2x equal to 2 sine cosine. Now if we double the angle, instead of 2x, we're going to double that, or we'll replace x by 2x. We're going to double all the angle. Or we just replace the x by 2x, so we have this x by 2x, x by 2x, and that's what we have. So 2 times sine 2x and cosine 2x, that gives us sine of 4x. And finally we have 2 sine 4x cosine 4x. So that is a double angle of sine, going to be double of this angle, so going to be sine of ax. And that's what we have. This problem is an application of double angle. We have double angle using sine, cosine, and tangent. So let's just write the formula, then we will determine what we need. Sine of 2 theta is 2 sine cosine, right? The cosine 2 theta, there will be quite a few things. We can say cosine square minus sine square, or there are 2 more, but let's just use that. And see, for tangent of 2 theta, we also have the double angle for tangent, but let's just use the quotient identity, and we say tangent is sine over cosine. We'll get back and find those values later. What we need is a values of theta, sine theta, and cosine of theta. We know sine of theta already. Just need to find cosine. There are a lot of ways to do this. We can use the right triangle. Just go over that quickly. I'm not going to use that, but so we say sine is opposite over hypotenuse, and then we go from there. We find adjacent, and then we find cosine. Right. I'm using Pythagorean identity instead. We will have sine square plus cosine square is 1. So we have sine square negative 5 over 13 square plus cosine square equal to 1. And that will be 25 over 169 plus cosine square equal to 1. Subtract that on both sides. We have cosine of theta, cosine square is equal to 144 over 169. Taking the square root on both sides, we should have cosine theta equal plus or minus square root of 144 over 169 will be plus or minus 12 over 13. Right, then we just need to determine the quadrant. It is given that it is in quadrant 3. Now in quadrant 3, the x value is negative, the y value is negative, and the cosine will be negative. So we have cosine theta is negative 12 over 13. Right. And when we have that, we just substitute it back in, and we will have sine of 2 theta is 2 times sine will be that, and cosine is that. So multiply straight across. 12 times 5 will be 60 times 2, 120 over 169. Next, we have cosine square minus sine square. So look like we still have 169, and we have 144 on the top. Minus 25. So we will have 119 over 169. And then tangent sine 2 theta, which is 120 over 169 divided by 119, 169. Multiply reciprocal, we should have 120 over 119. And we just that. So when we have the double angle, we just expand, and then in this case we have sine, cosine. We have sine already, we just need to find cosine. And we have the Pythagorean identity. When we know one of the sine, cosine, we can find the other. The quadrant will give us the sine of the trig function. Put all together, and that's what we have.